So let's start with the unpacking. As we know that the new syllabus has been launched for chemistry, and we all are still trying to figure out how it is going to go. So let me tell you something about myself. I'm Megha. I work in Aga Khan Academy, Hyderabad, India. I'm an IB examiner for HL Paper 2 as well as IAS. I am a workshop leader, and I try to give back to the community, which has helped me to grow as an IB teacher. So if we start with the IAs, it is common for both HL and SL. IA, it is to demonstrate everything that we have taught them over the span of 2 years. It has to be a scientific investigation, duration 10 hours, and it is weighted 20% for both HL and SL. The number of words that is designated for this work is 3000 words. As previously it was 12 pages, and we knew that what our students did, they fidgeted with the page margin, they fidgeted with the font style, and they crammed many words, more than 2400, which was permissible. And they just said, okay, it is as long as it is 12 pages, we should not have any objection. And we actually didn't have any proof to make them limit to 2400 words. So right now it is 3000 words, which is fixed for both HL and SL. That is exactly 1000 words less than the extended essay. So if a student is doing a good IA, we may expect him or her to do an extended essay in Chem as well. Let's see what is included in the word count. The title of investigation is included, the IB candidate code for all groups. What does all group mean? We will understand this uh, uh, in some time. Then actual number of words, and we don't have to include a cover page, an abstract, or a page of content because this will be included in the word count. What is not included is the charts and diagrams, data tables, equation formulae and calculation, citation or references, bibliography, and headers. Internal assessment can be a hands-on practical lab work, it may be a field work, it may be a spreadsheet for analyzing models, or it may be a work on extraction and analysis from a database. In case of pandemic, as we were limited to database and simulation, we may encourage students who are not very good in performing lab to continue doing this using this simulation and database. What is new in Chem IA or in Science IA is we have allowed collaborated work. Collaborated work means that a group of students can work together on a common topic. The number of students which are limited to group work is 3 students. The 3 students can do the IA together, but they should have a different IV. If they have the same IV, their range should be different. Again, if they have selected different range from that of their friends, they can collaborate the data and form a bigger IA. So if we go back to a guide, the guide says suppose A, B, and C, 3 students are doing the IA together and they are measuring, doing the same set of materials that is required. Let's say they are using calcium carbonate and hydrochloric acid. All of them want to measure the rate of the reaction. Now, this rate of reaction can be measured in 2 ways. Either we measure by how much amount is the weight of the flask, conical flask, where the contents are added, it is changing. The other student might want to figure out how much is the amount of gas collected after the whole reaction is over, or the third student may want to say how much is the gas collected in 10 seconds of time. So they don't have to change the setup of the apparatus remains the same, but what are they measuring that is going to be different in all the 3 students. Again, their lab report has to be submitted as individual lab report. Their methodology, their method, their IV shouldn't match at all. This is going to help those students who find it difficult how to arrange the data or how to arrange the setup so that the control variables are well maintained. It is going to be help of those students who are not very good in lab work. So their friends, maximum two, can help them in setting up the apparatus, but rest of the thing they have to do on their own. So this is a new thing which is included in 2025 IA. A school can also generate a database and using standardized protocol, and the student can use that database to extract data and do their own IA work. For example, if the school wants to say how is the amount of carbon dioxide release in a vermicompost pit changing after every day. So, the school may have a person employed who is recording the amount of CO2 which is generated by a compost pit, and that data is recorded. Now, the students can extract data from the database and say how is the temperature changing over an interval of 1 month or in the intervals of season. So, that is also allowed in this new IA. The rubric against which they are measured, previously it was peace, personal engagement, exploration, analysis, conclusion, evaluation, and communication. So they were marked against these. Right now it is race. If we try to remember it using a mnemonic, R is research design, A analysis of data, C conclusion, and evaluation. So what is the difference over here is previously conclusion and evaluation were assessed together. Now it is all separated. The good thing is maximum marks for each criteria is 6 only, and the total adds up to 24. Out of that, 20% weightage will be taken for assigning their final grades. So research design, if we go by the rubric, it is different. It is described by specific and appropriate context. Since it is a Chem IA, they should be limiting their research on chemistry. Many a times, those students who take in India, they take biology and chemistry together, or physics and chemistry together, they are more inclined towards biology or physics aspect of chemistry. So, if they are measuring the rate of the reaction, they will try to measure using an enzyme. Now, if they are using an enzyme, of course, enzyme affect the rate of reaction, but they will have limited amount of work to do in chemistry to justify it, to explain what is happening. It will be more bio lab than your chem lab. So we should be mindful of the fact that the research should be focused on chemistry. The methodology should allow to collect relevant and appropriate data. If we go more ahead in research and design, we should know that it should have a specific range of variables, independent variables, dependent variable, why this method has selected or why this database has been chosen should be elaborately explained. Control variables should be specifically designed in such a way that they don't affect the IV or the DV. Safety, ethics, and environment, or as we abbreviate it as C, should be properly taken care of. The hazardous chemicals which are there, they should be listed properly. So let's look at some research question. Let's look at research question 1. How does the amount of time for which the current is passed in aqueous electrolyte affect the increase in mass in grams of aluminum anode? Here we can see that the IV is identified as the amount of time, the DV is identified as an increase in mass, but this research question doesn't give us the range and the unit of your IV. So if we look at RQ2, it tells us that the amount of time they are limiting it to 600 seconds, 1200 seconds, and so on. And they are measuring the amount of mass increase at the aluminum anode. IB says that a good research question should also show the collection of qualitative data. So if we look at the second example, how does temperature affect calcium content in milk? Of course, this IA RQ is not properly uh, elaborate. Whereas if I look at the second RQ2, how does the temperature at which the Amul Taza milk is heated, they have told us the range at which they are heated affects its calcium content. They have told us the unit in which the calcium content will be measured. Also, how it is going to be measured, because calcium content is a secondary DV. You cannot measure it directly. You're measuring it indirectly. How we are measuring? The student has specified that they are going to measure the change in volume of EDTA, and they have also told us what will be the qualitative change. They have told that the milk solution will change from purple to blue because they are using EBT as a indicator. So if we have to specify RQ, remember RQ is going to finish 75% of your methodology. So it has to be complete so that the student is focused for the rest of the IA, that this is what I have to limit myself to. Again, there is a difference between method and methodology. Method is just like a recipe. What you have to do, you read the instructions and you carry it out. You don't dig deeper, you don't think about what you are doing. So, of course, we want the method, but more importantly, we want the methodology. Methodology means you are including the reason of taking that particular amount of the chemical or setting up an apparatus in that particular way. Methodology is, of course, going to include the method also, but if you are just writing the method, the amount of marks that are guaranteed is 6 marks. So if it is just method, those marks will be a little bit difficult to get. So we should ensure that a student describes why they are doing what they are doing. They may want to do a pilot study, and of all the three, let's say if they want to measure the caffeine content in a particular brand of coffee. So there are various methods of finding the caffeine content. If they do all the three as pilot, they collect data and they justify why we are choosing this method, not the other two method. That would be wonderful. This is a small checklist that I always give to the student. We should have at least these so that our 6 points are guaranteed. A research question, variables, student usually write independent, dependent, but they are confused between correlated and control variables. Control variables, they have been doing from MYP. Correlated variables, they consider them also to be as control variables. For example, correlated variables are such that if you control one, the other is automatically controlled. You don't have to write it down again. Example, temperature and pressure. So in a closed system, if we are increasing temperature, it is going to affect the pressure for sure. So we don't have to write that also as a control variable. We can list them all up as a correlated variable. We should have a theoretical background of the investigation that we are doing. If we are finding out the rate of the reaction of, let's say, how does temperature affect the rate of reaction, so we should have the relevant theory related to temperature. We should have the relevant theory related to measuring the uh, temperature and the rate. How is the rate affecting it? Again, since it is a chemistry IA, our work should be limited to what is the chemical process happening, how are the species or the chemicals or the reactants rearranging themselves to form a compound. So if that is explained in the background, it will help them to conclude in a better way. A hypothesis should be stated. Let's take this example only. How does temperature affect the rate of reaction? If a student is writing temperature, with increase in temperature, the rate of reaction will increase. That is good because that is usually what will happen as per their theory, what they have studied. But if a student says, with every 10-degree rise in temperature, my reaction rate is going to double, right? That is going to have many connotation related to it. That means if with every 10 degree my reaction rate is doubling, if I increasing the temperature by 20 degrees, the reaction would quadruple. So there are many conclusions which can be fathomed or justified using the terminology that we are using. So, hypothesis, as far as possible, we should not quantify it. It should be just qualitative that it will increase. We shouldn't link it to a number because it will be difficult for us to explain all of this when we are concluding the essay. Your steps should be shown properly. If you are doing experiment and you find that this is not working, I want to change it, those procedural modifications should also be shown over here. Again, the list of material and apparatus should be complete if at all they are writing. How will the list of material and apparatus help them? Every material that they are choosing is going to come with their own uncertainty, and finding out the percentage uncertainty of the apparatus will help them to write a good conclusion that since my apparatus uncertainty is less than 5%, that means my data is reliable. So it's a good idea to include the complete list of material and apparatus with their uncertainty. If we are using any hazardous chemical, how we are disposing it, we shouldn't just say, okay, dispose it off in a sink. All chemicals comes with their CLEP card, or if you want to use any other database, how to dispose the chemical should be specifically stated so that the environment is least affected. Students often suffer by writing what is the ethical issues which are going to be there. So for that we say that we take a limited amount of chemical so that my resources are saved. Next comes your analysis of data. Very easy to lose marks in this one because there are so many calculations which are involved in this. We are recording the data, we are recording qualitative and quantitative, and we are processing the data for uncertainty, and we are plotting a graph. This is going to link to my inquiry 2. What is inquiry 1 and 2? We will discuss in a little bit amount of time. So we should have a clear communication, how we are collecting the data. Is there consideration for uncertainty? If we are ignoring a value, there should be a reason for ignoring that value, why we are considering it as an outlier. We are going to discuss more about it. In-text citation is a good idea. In-text citation is a good idea to record whatever you think the examiner might need. They say any citation that we are doing should be uh, uh, it should be easier for them to be traceable on the net. So that link should be there in the bibliography also. So again, this is a checklist. What should be included in the analysis? Raw data, qualitative data. All the tables should be numbered and should have a heading as well as the uncertainty associated. It's a good idea to include 5 values. 5 times 5 is the best, but if your IA is long, it cannot be covered in a span of 10 hours. The IB says you can also take 3 values. That's also allowed. Uncertainty propagation should be done parallel to your actual value calculation so that there is no ambiguity and it's easier for the examiner to see how is the student processing the data. The final graph should be half a page big. It should be clear, the axis should be clear with the value, with the unit, with the uncertainty. The graph should have a title also. Last comes the conclusion. Conclusion is it again links to the inquiry 3. Conclusion should be justified to the research question, to the hypothesis, and it should be compared to a scientific value. Now, when the students are trying to find a scientific value, they will just go on Google and type, let's say, what is the calcium content in milk? So it's not a good idea for student to use Google to find information about science. Instead, they can go to Google Scholar which is going to give them online paper and material so that they limit their discussion based on a published material. If they want, they can also take the help of data booklet, which is published by IB, to come up with the theoretical value. So for conclusion, we have to use five things which are a must. First, it should answer the research question. If it is answering, good. If it is not answering, you should have a reason to support it. The conclusion should also answer the graph that is plotted in analysis. The conclusion should also answer how are the outliers not following the trend and what might be the reason. It should also refer to a fully referenced literature value if it is possible to procure it. And it should also support the theory why is the results deviating or what is the source of the error. Again, many students find the R square value if it is a graph and they try to support their observation by doing that. Last comes the evaluation. It also links to the inquiry 3. Evaluation, we have to assess our own methodology for weakness and provide improvements. So we have to list all the, for evaluation, usually student make 3 columns. They will tell this is the error, this is the source of the error, and this is how we can improve. And they consider if we are writing error evaluation, evaluation is all about errors. Evaluation is also about the strength of your IA. Why do you think your IA is good, or why do you think your data collected is good? So our evaluation should start with the strength. Okay, this is my strength. Instead of using a mercury thermometer, I use a digital thermometer so that my apparatus is more precise. That is a strength. So start with strength, then come to the weakness. How is your data limited to the apparatus that you have used, or how is your data limited to the amount of data that you can collect in a span of 10 hours. They say that when you are recording your evaluation, you should also show what is the direction of the error. For example, if I say temperature affecting my rate of reaction and my temperature, it was difficult for me to control the 5 degree or 10 degree or 70 degree temperature on the water bath. It was not easy for me to maintain that. So of course, when the temperature is not maintained, it either it may be a lower temperature than recorded or a higher temperature than recorded. So when you are writing the error, you should say that we have recorded a higher temperature. This means my rate of reaction will be higher than the expected value. So the direction of your systematic error should also be specified so that the examiner knows that you are aware of the error, you are aware that this is systematic and random error, you are aware of the significance, and you are also able to tell how is your value going to be affected in a directional manner. So we should try to discuss the weakness. We should also try to do a small para on further investigation. Further investigation means next time if you have the time and opportunity to do this IA, what is the thing which you like to do it further? And we should conclude our IA with a well-written bibliography. To make this possible, to make this 24 hours, 24 marks possible, there are some skills which are listed in our chem guide. First is the tools and next is the inquiry process. Tools are the experimental techniques, technology, and math. Inquiry process is exploring, collecting data, and concluding. So the whole IA cycle is based on this inquiry process. If we go by this example from the IB Chem guide, the small circle is the whole IA that we are doing. And as an educator, it is our responsibility to ensure that we are giving them enough help in making them perfect with these 3 strands. Again, if we are going to make this possible, we have these three tools: experimental technique, technology, and math, which should be embedded, whose examples should be given as classwork or in the homework so that the student are aware of the techniques, tools which are used in your IA. To summate it, I have taken extracts from the Chem Guide. These are the tools, these are the techniques. Techniques, you can also remember them as compulsory labs. These are labs we should cover. And these are the skills which are used. For mathematics, for making them good in analysis, we should make them aware of all these calculation in the span of 2 years of our time. So processing uncertainty, graphing, what they should know is clearly listed. What I have also done is I have made a Padlet which has all some links of resources for our session. So that was for me. Thank you so much for joining. Let me post the link of the uh, Padlet. Any question anybody has? I can see one question. Random error calculation person. Yeah, random error. Uh, percent uncertainty can be calculated by different ways. When you are doing your actual calculation, let's say I'm finding the rate of a reaction by measuring the amount of gas generated. So the calculation that I'm doing for rate, parallelly, I am doing it for the apparatus which are used to calculate the rate. So when you are doing those percent uncertainty calculation, you convert it to absolute uncertainty and then you quote your final answer. So IB needs both the absolute uncertainty also and the percent uncertainty also. Students, those of them who are doing a group work, they can have similar control variables. But since their IV is different and their DV is different, they might have different control variables also. In one IA topic, if they are doing collaboratively, no more than 3 students. 3 is the maximum that should be there. If you have any more question, there is a section on the Padlet where you can ask question and I will try to answer. Any other question? This unfortunately this meeting is timed, so we have approximately 7 more minutes. Does anybody else have a good practice to share? It's not a IB workshop, so we all share our good practice, what we are doing, what is going on good. We also have a section on Padlet, which is having some suggestion. If you want to give a feedback, I have not made a feedback form. So if you think that I need some changes or some improvement, please feel free to share there. Let me show you how does the Padlet look like. Padlet is something like this. The PPT which I used is here. So if you want, you can use it. In further, there are some examples of hands-on lab. Since we don't have any examples from the new curriculum, these are all from the old curriculum. There are some examples of online labs also. There are some checklists which I have taken from different sources and to make the students know okay, this is what is required in IB. How to propagate uncertainty, I found some articles. And this Hodder Education link is excellent. It has all the help that we might need for to deliver the new curriculum. There is one example of online graph plotter which I found interesting, which we may give to the student to make them good in plotting graphs. There are samples from IB 2025 which I have taken from IBO. It serves as a good way to correlate all the resources. And there are some activities to blend simulation and data sheet. I hope you will like it. Any question and suggestion you may give in the last column. So
Ma'am,
six.
excuse me, I have one doubt. One of my student is from SL and she wants to do an experiment on calculating the rate of reaction activation energy. So can she do it?
Yeah, there is no
Because
limit
it
to
is
it.
in HL syllabus.
I know the students has to go ahead and uh, explore it. When the IA goes, it doesn't go as a SL or
HL.
an HL student. So if the
Yes,
student can
can
go
go.
beyond and study it on their own, that is absolutely fine.
Thank you.
This Padlet will be working for quite some time until I am short of Padlet. So it won't go very soon, approximately 3 to 4 months it will be there. You may download anything which you find interesting. And if you want to share anything with anybody, you can add on this Padlet also. It's fine to help each other.
Thank you so much, ma'am.
Thank you for joining. Any other question anybody has?
Hello, ma'am. I have a question regarding IA investigations. Is it okay to compare techniques or
Comparing
can?
techniques is like it will be difficult to finish this off in 3000 words. Many students compare techniques and it works wonderfully well with extended essay. So maybe it's a new thing, 3000 words, if they can compile it up and find okay, how does, let's say, preparation and purification of aspirin by one method versus the next method. If they can justify it, that's wonderful. They can do it. We have 3000 words.
Thank you. Thank you very much.
The recording will be shared by Ms. Ashika and team on YouTube. I will also put it on the respective groups once it is done. So,
Ma'am,
yes, ma'am.
hello.
Yes, ma'am.
Yeah, is it okay to mention the brand name? Because in one of the exemplars you displayed, like milk, the thing, you mentioned the brand name. Is it accepted if they mention the brand name in RQ research question?
Yeah, they can. IB says we
Because
shouldn't compare
uh,
brand. We should not compare
yeah.
brand. That is what IB says. So that person is not comparing brand, but just quoting which brand of milk they are
Uh,
taking.
okay, sure.
Yeah.
Okay,
If it
yeah,
was
thank you.
Amul Taza milk and any other brand of milk, that would be not a good
Hmm.
idea.
But we should not, like conclusion, we should not say that this one is good than the other brand.
Yeah,
This
correct,
is not
correct.
acceptable. Yeah.
Comparison of brand is not good, but since she's using the same brand of milk and changing temperature, that is why that student might have written.
Okay, thank you. Thank you.
Thank you. So this new syllabus is difficult, everything is same, but previously it was a chapter, whole chapter, chapter 11 on data processing and analysis. Now we have to teach all the techniques as a separate part of the syllabus. So putting that all together in labs is a little bit taxing job. That's what I am finding in this 6 months. It looks good, it looks easy, but when you try to put things together in the labs and making the students do, they always question why we are doing it. Are we going to be assessed on this? Which chapter it is belonging to? So it doesn't belong to any chapter, but we have to teach the skills, we have to teach the techniques. So all the best to everybody of us with this new
Thank
syllabus,
you.
and we will
Thank
continue
you, ma'am.
having these
Thank you.
sessions in future. Thank you for joining. Thank you so much. Thank you. This meeting will end in less than 1 minute. That's what.
Ma'am, I have one question. Like in for HL and SL topics, Pearson's, I really like it, but then it is like in the same page, you have SL syllabus, you have HL syllabus. Is there like earlier Pearson used to have SL separately and HL separately?
Correct. Yeah.
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 So
Mm.
which one, Oxford you are preferring or Pearson
No, I
only?
still like Pearson because the language is very smooth.
But
I
then
asked
for
it,
SL students, if we are recommending, like,
I ask